We now need to look at the instruments that we use when we are making surveys of pipelines. The most common survey is known as the close interval potential survey. And the idea is that we measure the voltage between the ground and the pipeline so that we can estimate if the equilibrium between the pipeline metal and the ground is such that current, electrical current, is flowing onto the pipeline and not off the pipeline. If current flows from the pipeline into the ground, the electrolyte, it causes corrosion. Metal goes into solution according to Faraday's laws, where the amount of current is proportional to the weight of metal loss. Right, so the most common instrument that we use for these surveys is the data logger. And this data logger is plugged in to the computer, and this computer displays and records the voltages that are measured by the data logger. The voltage is the measurement between the potential of this through the measuring circuit to the potential of this, which is the nail which is protected from corrosion by the charges that are being impressed into this nail, travelling through the electrolyte and being received by this nail to complete the cathodic protection circuit itself. Now, this is not the corrosion circuit. The corrosion circuit does not include the copper sulfate ground contact electrode. The corrosion circuit is from the battery to this nail, through the electrolyte, to that nail, and directly back to the battery. That is not what we are measuring with this procedure. Has been known as pipe to soil potential measurements, and of course the measurement is not a potential, it is a potential difference, it is a voltage. You will see that when I lift this, it breaks the measuring circuit and the voltage goes down to zero. The other instrument that I've connected up to is a Dr. DAC digital oscilloscope, and I've set this oscilloscope to measure voltages. It does this by displaying a trace of the voltage between the connections of the probe that feed into the oscilloscope. I've connected the probe, which is this connection, comes from here through to here, and I've connected this via the green connection to the same contact point as the meter. So this reading is a more sensitive measurement, and it shows that it is fluctuating, and the fluctuations are in fact in this metering system, but this metering system actually takes samples, and this metering system displays all the measurements. Right, When I lift this, you will notice that this trace reflects that there are still voltages, and some people regard these as AC interference. But in fact it is not. It is Tesla energy which is everywhere, and this meter is sensitive, this oscilloscope is sensitive enough to record all this fluctuations in energy levels and make a graph of the voltages. So that's the readings that we're taking. Now at a later stage I will fix in a timing device to switch the cathodic protection current on and off. And we will be able to see the waveforms that are shown on the oscilloscope. Hope that was helpful.